So we left off talking about the digestive process and what happens in the small intestine. What happens in the small intestine? Yeah. Still digestion though, don't forget. There's a lot of digestion going on in the beginning portion of the large and small intestine. We have a lot of enzymes still coming in from places like the pancreas, and we have some emulsification coming from the gallbladder. What's emulsification? Actually, it's what? It's breaking apart the fat, because lipids are hydrophobic molecules. Do you know what that means? They don't like the water. They repel water. So when they hang out together, they hang out in clumps. In order to break them down, and do you know what they're made of? What are the building blocks? Well, that's proteins. Lipids. 2 parts. You got nothing? Glycerol and fatty acids. So those are the things we want to have so we can use them to build our fats. We store our fats as triglycerides. So we have to break them apart before we break them down. And bile is actually going to help break lipids apart. It's an emulsifier. It's almost like soap. You know when you go to the supermarket and you buy soap? In the old days when you bought soap, you had to buy a big, huge, if you wanted to buy liquid soap, big, huge container, right? And then when you put the soap in the washing machine, you remember how much you had to put in? For those of us who remember back then, you had to put like a cup, a whole bunch. Do you have to do that nowadays? No. Why? Yeah, somebody figured out, smart, suck all that extra water out. We don't need the water anyway. We're putting it in the washing machine. Let's concentrate it. And that's what the gallbladder does for us. The liver makes a substance called bile. The gallbladder concentrates that bile. And that bile is the emulsifier, like the soap in the washing machine. That's going to help break apart the lipids so that enzymes secreted by the pancreas can break them down into their glycerol and fatty acid components. So once we get most of the breaking down done, we also are going to then start the absorption process. So small intestine breakdown, mostly we think of it as absorption. We're going to take those small molecules now that we've broken down to its small components and deliver them to the cells throughout the body. Who's going to do the delivery? Who delivers all these molecules that we broke down in the digestive? Who? You said it. Say it again. Who? Nope. Blood. Blood's my delivery system. So I have to absorb what I broke down in the digestive system into the circulatory system for delivery. So most of that absorption is going to take place in different compartments within the small intestine. Small intestine is, do you remember how many feet I told you it was? Yeah, from here to there, bang, about 20, 21 feet. And it's broken down into different compartments. The duodenum, the jejunum, and the ileum. In order to get the most bang for my buck, the most absorption I possibly can, what I want to do is increase surface area. The more I can increase the surface area of this tube, where all of this goodness is taking place, the more absorption, the more breakdown I can have. So in order to get the biggest bang for my buck, say in a space this big, if I take the lining of that tube, and instead of making it straight like this, if I take the lining of that tube and create these little infolds, what does that do to my surface area? Yeah, like doubles it, doesn't it? probably even 2.5 if I stretch this out. Those are called villi. So if I look on the inside of that small intestine tube, I'm not going to see a straight line of cells where absorption takes place. I'm going to see these little finger-like projections. So I double, almost triple the surface area or the ability to absorb that material. If I take a close look at those cells that line this with these little finger-like extensions, I'm going to see more little finger-like extensions on the cells themselves to further increase surface area. These are called villi. Guess what these are called? These are called microvilli. If I look at them under the microscope, they almost look like a brush, like to brush your hair. And guess what we call those cells? We call them the brush border. So the brush border is what's going to make up those little microvilli and villi that further increases surface area in the small intestine. Those cells are also going to make enzymes. Those enzymes are going to continue the breakdown of nutrients in the small intestine. So absorption can happen through a couple of different mechanisms. Do you remember the terms endocytosis and exocytosis? Hopefully you learned in your biology class or your anatomy class. So cells can do what? Yep, they can take things in, pass them through themselves, and do what? Shoot them out the other side. We can do that with water-soluble nutrients. We take those nutrients, carbohydrates, proteins, minerals, vitamins, ship them through those cells, and give them to who? The circulatory system. Well, the biggest guy that's going to pick up in the beginning from the intestines is a group of veins called the portal veins. Portal veins are going to transport nutrients through the liver, kind of a side trip that they have to take. Sometimes we alter things a bit before we send it into the general delivery of the circulatory system. Fat-soluble nutrients are much bigger, so we have to deliver them a little bit differently. There's another group of tubes that we have running through our body that carry fluids besides the circulatory system. It's called the lymphatic system. And the lymphatic system works hand in hand with the circulatory system to help take care of fluid balance throughout the body. We're going to pick up some excess fluid when it leaves the circulatory system during exchange and put it back into the circulatory system with the help of the lymphatic system. But the other very important thing the lymphatic system does is also helps to absorb lipids. Now remember, the lymphatic system goes back to the circulatory system, right? So those lipids are going to take a side trip through the lymphatic fluid before it gets dumped into the circulatory system. So again, if I look at the tube, I'm going to find a tube with these little finger-like projections that I can see, villi. And the cells, these little guys, have microvilli. Within these little villi, I'm going to find tons and tons of blood vessels because the absorption is going to take place through these cells and then into these vessels. So the blue and the red ones are what? Arteries and veins. What's the green one? That's the lymphatic vessels. They're called lacteals. And this little system of tubes is going to help with the absorption. All right, so we did absorption, we did breakdown. What do we have left to do with what's left? Pass it on down the tube. Who's next in line? So we went through the 21 feet. Who's next? Large intestine. So the large intestine is next in line. We have another little check valve at the end of the small intestine. Guess what it's called? It's called the ileocecal valve. The ileum, which is the last portion of the small intestine, and the cecum, which is the first portion of the large intestine, is where we're going to find the ileocecal valve. Now, food is then passed after most of that absorption takes place to the large intestine. There's still a little bit of digestion, believe it or not, that's going to go on. And I think we mentioned this earlier in class. Who's going to help me digest or break things down in the large intestine? Anybody remember? Bacteria. Yeah, bacteria. So we have some bacteria in our gut, our normal flora, it's sometimes referred to as, that's going to help release some important vitamins, B vitamins, for example, vitamin K. These things are going to be released with the help of those bacteria. So very little digestion is going to take place. Even though it's little, it's important. About 12 to 24 hours, material hangs out, gets broken down a bit. We're going to suck up some of those vitamins. And what else are we going to do to this whatever's left from the small intestine? Take out some excess what? Water. So water and nutrients are absorbed, and then where do we go? Out. So the large intestine has sections as well. The beginning is the cecum. That's not the cecum. What is that little thing hanging down? That's your appendix. The cecum is actually here. What's the appendix for? Actually, we're getting to know more and more and more about the appendix. We thought it was useless for many, many years. Some people, evolutionary studies, people who study evolution, thought that maybe it was there to help us digest cellulose, which we can no longer do. But we're actually finding out that that appendix is sort of our stockpile of good bacteria. So every time we pass our feces, we also pass a whole bunch of what? We pass those bacteria that are actually useful to us. So we kind of stockpile it in the appendix to give us a new infusion of bacteria periodically. It's also lymphatic tissue, so it helps with an immune response. So it's not really as useless as we thought it was so many years ago. It's actually going to do us some good. So we have the cecum, the ascending colon, going up. Then we have the what? Going across, transverse colon. Then we have the descending colon going down, sigmoid colon, rectum, and then my final destination, the anus. So the large intestine, even though there's not tons of things going on there, it's extremely important. That bacteria is going to help with vitamin absorption, water balance, and it helps us get rid of the waste. So, some of the disorders related to digestion. Anybody get heartburn in here? I'm Italian, so we call it agita. Yes? What is that? Nasty agita. Huh? Besides being a pain in the neck, what is it? Yeah, those little valves, the little check valves. What was the one called? The gastroesophageal sphincter muscle. Sometimes if they don't close the way they should, and there could be many reasons why, there's a condition called hiatal hernia that can cause this problem. But for whatever reason, overproduction of acid and not closing that check valve properly can result in acid washing up on the esophagus. Now the esophagus and its cells weren't made to have acid on them. Gastroesophageal reflux disease is persistent heartburn. Probably everybody's had heartburn at one time or another. Bad chili, too much garlic, But when you have it persistently, daily, or every other day, you fall into that category. So it can create problems with eroding the esophagus. It can also, excessive acid production can cause problems down the other end with ulcers. So regions in the gastrointestinal tract that have been eroded away by hydrochloric acid production. What do we have in the stomach that was going to help protect us from that erosion? Mucus. But sometimes different conditions will cause patients to decrease the production of mucus and increase the production of acid. And this is where we run into some problems. So ulcers. Another nasty little bacteria called Helicobacter pylori can also do what I just said, cause us to decrease mucus production and increase acid production. So we see gastric, stomach, and duodenal. Where's the duodenum? Yeah, that beginning portion of the small intestine. We can see a strong correlation between this bacteria's presence and ulcers in those regions. Oops. I got a little too far. Diarrhea. Why is that bad? For so many reasons it's bad, but why is it bad digestively? Yeah, you're losing a lot of water. You're losing a lot of those vitamins and ions that you would have absorbed from the large intestine because things are moving too quickly through that digestive tract. It can be for many, many different reasons. It can be because of some nasty little critter that got into your digestive system, or it could be due to allergies or infections, you name it. But anything that causes things to move too quickly through that large intestine region can be a problem. It can be caused by food intolerances. It can be caused by stress. Did anybody have diarrhea when they get nervous? You don't have to raise your hand. You know who you are, right? So any of those things can lead to excess peristalsis, quick moving through the digestive system. It can lead to severe hydration, very dangerous for those two ends of age, children and the elderly. The opposite is just as much of a pain. When things don't move quickly enough, what can happen if things don't move through the digestive system the way they should? We're plugging up the works, and that if you've experienced the other opposite of diarrhea, constipation, that's not good. It can be very uncomfortable, can cause all kinds of problems, and can actually cause perforation of your bowel if it gets to a bad point. So now, not to get up close and personal with you, but think about it. How many times do you pass stool in a day? How many times should you? How many times do you eat in a day? 2, 3, daily. Not weekly, not monthly, daily. What can help you do that on a regular basis? Fiber, bulk. Yes? So that, and water. Sometimes when you're dehydrated, what are you going to do to that stool, well, the feces that's left in the large intestine? You're going to suck more water out to help with water balance. So exactly, you need to be hydrated as well. So if no stool passes for 2 or more days, you're constipated. If that's normal for you, you need to do something about that. Because we want to be moving that stuff through on a regular basis. Yes? Irritable bowel syndrome, and that's usually what a doctor diagnoses when he's not sure what is causing your problem. But irritable bowel syndrome is a disorder that interferes with normal colon function. And it can result in bouts of diarrhea and constipation. Depends on the patient. It can cause a lot of cramps and bloating And again, it could be either diarrhea or constipation or a combination of both. Very common in women, more than in men. Food intolerances. Almost like allergies. Can cause unpleasant symptoms. Anybody have any food intolerances in the gang? What do you have? What to what? Yeah. And we're finding out that a lot of patients that were diagnosed with irritable bowel syndrome actually have this problem. And it's not a fad. We're just realizing, oh yeah, that's what it is. Doctors are realizing, talking about celiac disease or wheat intolerances. Cause a lot of pain, gas, diarrhea, or constipation, or a combination of both. Food allergies or hypersensitivities, kind of like when you get poison ivy. Think of that happening inside your small intestine. So you're going to have all kinds of problems with absorption and secretion, problems with water balance. I'm going to have you watch this one. It's a good one.
Now to a new study that may turn everything you thought you knew about food allergies upside down. It turns out as many as half of us who think we have allergies really don't. Our Dr. Richard Besser has more.
Seafood and nuts.
Milk allergy.
Fish.
Peaches.
Nearly 10% of the U.S. population believe that they have a food allergy. But a new study says that as many as half may be wrong. The problem is testing. Traditional methods such as the skin prick test and the blood test only indicate if the body produces antibodies, but doesn't necessarily mean that the body can't tolerate the food.
Are any of the tests that are done for a food allergy better than any other?
The oral food challenge is probably the most definitive, and it's what we call the gold standard, because there we're actually having the person ingest it and see whether or not symptoms come on. The problem with doing that is it puts the person at risk of having an allergic reaction.
But some are worried that this study might make people less vigilant about food allergies.
It presents one side of the story. We absolutely should exercise precaution until further testing and further science is available.
I'm going to clean you with alcohol.
Oliver, who has suffered from food allergies all his life, is being retested.
He has food allergies to milk, dairy products, egg, fish, and possibly tree nuts, but the dairy allergy is a life-threatening allergy.
Oliver gets a common test and an oral food challenge every year. This year, good news. He's outgrown his peanut allergy, and his body can now handle eggs and baked goods.
Now that I'm not allergic to baked egg, it's easier for me to eat stuff.
And Rich Besser joins us now. So much to get into here, Rich. Let's begin with this critical distinction. You got a lot of culprits.
That's right.
For allergies here. But a lot of people who think they have allergies may simply be intolerant of food. What's the difference?
They are different. A food allergy is an immune reaction. So your body treats the food as something foreign and tries to take it on. An intolerance is something like lactose intolerance, where your body may not make the enzyme that's needed to break down the sugar, and so you get symptoms like bloating and diarrhea. Very different than an allergic reaction, which can be life-threatening.
So how do you account for this, what appears to be some overdiagnosis of allergies?
Well, a lot of it has to do with the tests, which are not very good. If you think you have a food allergy, you need to see a doctor, and the most important thing they're going to do, or should do, is talk to you and find out what type of reaction did you have when you ate the food. Was it something where you had hives, or you had some tickling in your throat, which are true allergic signs, or was it you felt a little nauseous, which may or may not relate to a food allergy? That kind of discussion is critical.
I was surprised there to learn about outgrowing allergies. What is that about?
You know, it's important to get checked regularly. 85% of children are going to outgrow their food allergies, so they should be seen every 2 years. Adults every 4 to 5 years. And if you're someone who was told you had a food allergy or think you do, but you didn't have those classic symptoms, see your doctor and get reevaluated.
And we were talking about something right before we went on the air that you really want to underscore. Go see the doctor. Don't try to test this yourself.
Right. Don't hear the story and say, oh, wow, maybe I'm one of the 50% who doesn't have a food allergy, because it can be deadly. And we need to talk about what you do in those situations.
Now, you do have a little demonstration here what to do if you do indeed have an allergy.
Yeah, if you're someone who has a true food allergy and you're at risk for a severe reaction, your doctor is likely going to give you an EpiPen. This is an injection of epinephrine, a drug that will treat you in the event that you have a severe reaction. Let me show you how that works. It's very simple. I'm going to use the training device because I don't really want the injection. This is what an EpiPen looks like. It's very simple. They're dosed. There's a junior size for children. There's an adult size, and it's based on weight. But it's very simple to use. You take the device, you remove the blue top, okay? You don't ever want to touch the orange where the needle comes. And you hold it in your arm, you go to your thigh, you swing,
ooh,
you inject. And you hold it there. This is the training device. Yeah. If it were the real one, I would not be smiling. Yeah. So you hold it for 10 seconds and you take it off, and you'll see that the needle is now covered. You want to then massage your leg for 10 seconds, but it's so simple to use and it's life-saving. If you have it, don't store it in your car, don't store it in the refrigerator. Make sure it hasn't expired, and make sure someone is calling 911 when that's going on.
And of course, that comes only with a doctor's
Exactly, with a prescription. But it's very important to have, and as your child grows, you may need to move sizes. If you're a large adult, you may need to.
Okay, Rich Besser, thanks very much.
Anybody have one? Have you? What now? What are you, bees or? Oh, all nuts. And it's hard. Isn't it hard to find products that? Right.
Mine was even the dust of peanuts or anything. I had allergic reaction in middle school. Somebody was throwing peanuts at me because they didn't believe that I was allergic to peanuts. My throat closed. I had to get rushed to the hospital because I couldn't breathe.
Yep.
And there was like a substitute. They didn't even know. They thought I was kidding, and they were just throwing peanuts around. And it took like 2 minutes, not even.
Yep. So people like you, and it's true, they are very sensitive to these products. I knew a girl once who was egg. Egg was her sensitivity, and she was very sensitive, allergic. Remember, there's a difference between sensitive and allergy. So we're not talking I'm getting a little gas and I'm going to fart a little bit. We're talking my windpipe shuts off and I stop breathing. Right, and that's the challenge part. So you have to be very, very careful.
Yeah.
And carry that EpiPen around. Yeah.
Right now, it's not, I've never had to use an EpiPen on him, but it was always like work.
Yep.
I found out with 8, I couldn't have enough, and, you know.
Yep, and had it.
And, we, brushing the dog and all that stuff, but I've never had to use that. My sister was supposed to, they told me, like, the more that he, as of right now, the more that he digests it, the worse that
It's going to be more violent.
So, like, you never know the next time he has it. He's run into peanuts twice now, and,
yeah, what do...
daycare, and then they made it peanut-free, whatever.
Yeah. And what, most, what did you give kids when I worked in daycare for a short period of time? Yeah, peanut butter crackers. That's what they gave them for lunch. And, lunch. How many? Check the lunch bags of half the kids if they bring their lunches anymore. They're getting peanut butter and jelly.
That was the reason my school switched over to sun butter, because the school was tired of paying for all the ambulance.
Yes. Well, and it's scary.
I couldn't even eat in my cafeteria.
Yeah, they had to separate. You know, they at one point they had the separate table, and you know that's terrible for a second grader. I have to sit at the separate table because I can't. Did you have a question?
All schools where my kids went to school in Dixfield, all the elementary, middle, and high school, they have peanut-free now, every one of them.
Yeah, because it's so common. And again, you know, we might see that your body changes. I never had seasonal allergies until I hit my 20s. Guess what class I was taking in college when I started my seasonal allergies? Vascular plant taxonomy. Do you know what you do in that class? You go out and you identify plants and weeds. And it was a fall class. It was horrible. I was out in the field with tears coming from my eyes, sneezing, and what's going on? But that didn't start till my 20s. Now I'm a little older than my 20s, and it seems my body is changing again. So your body and the way it reacts to your environment is ever changing. Yeah, bam. Ugh. But yeah, I would get to the point with the lymph nodes. I thought I had a giant brain tumor because the lymph nodes in the back of my neck were so swollen. I woke up one morning, my eyes were closed shut, and all the lymph nodes were swollen. I thought, I'm dying. And that's how my body reacted. It went in the 20s to seasonal allergies, you know, those allergens that were in the air. So yeah, it can change. You can grow out of it. Just a matter of get that testing done periodically. And then one of my theories, I worked in immunology for years, is when the body is hypersensitive to something, it seems to be more hypersensitive to lots of things. So when I was in my allergy mode, it seemed like I was more sensitive to everything in my environment. So, celiac disease. That is an allergy or intolerance to what? Gluten. What's gluten? It's a protein that we find on wheat. Wheat, barley, rye, grains. Can damage the small intestine. So if I damage the lining, if I keep beating it up, what's going to be the result? Yeah. If I beat up that lining, I'm not going to be able to continue the breakdown process, and most importantly, I'm not going to be able to absorb the things that I need into my circulatory system. So that's what the big problem is with a disease like this, celiac disease. So what do? Don't eat wheat, don't eat rye, don't eat barley. And because we're finding out this is such a prevalent thing in our society these days.
Can I ask a question about this?
Yep.
If someone has no problem with gluten or whatever, or just like the average person that's not, doesn't have celiac disease, can gluten is that something that irritates people as is? And
It can.
What?
It can.
And like take it out of your diet completely, it would be no problem.
Yep, it can. And there's a lot of studies that have been going on about this because we see the prevalence of celiac disease in our society increasing.
A bad follower, and he went to the doctor to get tested, and they said there's no problem. I just thought it was kind of bullshit. He's like, no, it really makes me feel better, blah blah blah. But
Because it's changed, our wheat and our barley and our rye have changed a lot since, say, if we look at gluten and the consistency of gluten 50 years ago, it's much different now because of all our different farming practices and our inbreeding and whatever we're doing, genetically modifying. What we've created is a gluten that is much larger a molecule. So we're finding that people aren't tolerating it as well as they used to years ago. So we are seeing a difference. And people are recognizing that, geez, maybe it's a simple thing like the bagel I eat every morning for breakfast that's just making me feel crappy. Now, with celiac disease, it's going to make you feel sick. But with someone like your dad who's thinking, maybe I'm having a problem with the digesting of this molecule. Maybe if I eliminate it, I'll feel better. So we do see that. So there's a lot of people now that are going gluten-free and saying that they feel better. Less bloating, less gas, and even some people, weight loss.
Yeah, I know a kid in my class who had because he had to get surgery, and they said he lose 30 pounds. And he dropped 65 pounds.
Just eliminating gluten from his diet. And it's not, nowadays, because we recognize it so prevalent, there's so many products on the market. So it's not like you never eat a sandwich again. There's bread out there, and some of it's pretty good. So I got a gluten-free brownie the other day. Oh, I'll tell you, that was a really good brownie. Yeah. Udi's, those little snickerdoodles, and they're good. They're good. I've had them. So yeah, we might see that it would help us to eliminate that, or at least not necessarily eliminate it totally, but decrease our consumption of it. So that's chapter 3. Let's do chapter 4. Any questions on chapter 3? So we'll be able to zip through this and catch right up, right? So now we're talking digestion. Since we're on the subject, let's talk about all the different things we get from our food, why we digest. And the first organic molecule that we're going to talk about in this class is something called the carbohydrate. Now, what's a carbohydrate? We're going to use it to make energy, yes. Sugars. There's a molecule called C6H12O6. Now we're getting chemistry on you. Who's that? That's glucose. Well, it's not just glucose. It's also fructose, believe it or not. But these are what we call simple sugars. And simple sugars linked together through a chemical process called dehydration synthesis creates what we know as the carbohydrate family. So it's one of the very important calorie molecules. How many calories do we get from a gram of carbohydrates? Kilocalories, I should say. 4. Remember that? There's 2 numbers we had, well, 3 numbers we had to memorize. What were they? 4, 9, and 7. Who's 4? Carbohydrates and proteins. Who's 9? Fats, lipids. And who was 7? Alcohol. So we're going to use this C6H12O6 at a cellular level to make energy. Now, energy, when I talk about energy in the chemical sense in the human body, what's that molecule I'm making called? It's called ATP, adenosine triphosphate. In order to make it, I need this, and to chemically alter this to make it. So we have carbon, hydrogen, oxygen. Do we have any nitrogen in a carbohydrate? No. Where are we going to get? Proteins. Where do we get it from? Things that do what? Grow out of the ground, because plants make this for themselves. They make this so that they can turn around and do what? Break it down. Well, photosynthesis makes this. Can you do photosynthesis? Nope. You don't have any chloroplasts. Sorry. But plants do. And they can take the energy from the sun and make this. Then what do they do with this? They break it down and make their energy, ATP. So where do we get this from? We take advantage of them. What do? We eat them. So we eat things that grow out of the ground, fruits, vegetables. They make carbohydrates for us. So the simple building block, sometimes we refer to it as a monosaccharide. Is that ringing a bell? What's a polysaccharide? Yeah, a whole bunch of them stuck together, right? Glucose is the most abundant carbohydrate, and we're going to change things chemically to make it. Produced by plants through photosynthesis. Found in plants, usually linked to somebody else. So, did anybody eat fruit this morning? Anybody have a cup of coffee this morning? Put some sugar in there. What's that? Sucrose. Do you know what it is? It's a disaccharide. It's glucose and fructose. So what do you think I'm going to do with that? Put in my coffee. Well, fructose is from the fruit. What do you think I'm going to do with it? I'm going to eat it. It's too big. What am I going to do with it? Break it down. I'm going to use the enzymes in the digestive process to break it down into its building blocks. So when I talk about transporting molecules through the circulatory system to deliver to the cells, it's usually found in glucose form because I'm going to break it apart from the foods that I eat. If I have something called a polysaccharide, I'm going to break it down in the digestive system and make it into the building blocks. So energy from the sun is going to chemically produce this inside plants. Now the plant uses some of it to make its energy, but it can store it too as a polysaccharide. So many of the plants that I eat, sometimes you hear the term complex carbohydrate. What's a complex carbohydrate? It's better for us because what? It takes longer to break down and distribute. It's a more even distribution, but the plant stores it for itself, so it can use it later on too. So a polysaccharide is a complex carbohydrate. Yes? So monosaccharides, simple, disaccharides, too. And again, these are common ones we see. We put some in our coffee. We ate some fruit. Lactose, what's that one? Milk. Maltose. That's ever eat malted milk balls? Malt sugar. It's not as sweet as sucrose, but it's still a disaccharide. Different monosaccharides, here's some examples. Glucose, again, that's the common guy. Fructose, that's what we find in sugar. What's that? High fructose corn syrup. Is that found in nature? No, it's not, even though the commercials try to tell you it is. Where do we make it? In the lab. And it's extra super sweet. So guess what? If I'm going to make a product that I want to be sweet, wouldn't it be cheaper for me to chemically alter and make this super sweet high fructose corn syrup so I don't have to use a lot of it? Save me some cash. Yes? But what else does it do? Messes with your body chemistry. shoots up your insulin levels really, really quick.
Wait, it's found in fruit?
No, fructose is found in fruit. High fructose corn syrup is altered fructose, not natural. Who's got anything on there? What's in there? Any high fructose corn syrup in there? No? What is it? Oh, it's good stuff. I thought it was cheery. No, it's not good stuff. I didn't catch anybody today. Shoot. There's a lot of stuff in there I bet you can't pronounce though. Yeah. What'd I say about that? You can't pronounce it, don't eat it. Especially if it's blue.
Good in fiber.
It's good. How many grams? Yeah, it says it's good in fiber. How many grams? 4. That's good? Well, I guess it's better than some other cereals. So these are examples of monosaccharides, simple building blocks that we'll find in our carbohydrates. This one's kind of bound in, doesn't typically occur by itself, galactose. And then those disaccharides, through the process of sucking some water out and sticking 2 of them together, we form lactose, maltose, sucrose. Our enzymes are going to do what to them? Break them down. Now, what if I don't have the right enzymes? Anybody have a problem with dairy products? What do we call you sometimes? Lactose intolerant. How come? Yeah. So when you take it in, you don't have the right enzymes. So that's going to go down into your small intestine, pass into your large intestine as this big, huge sugar molecule that I couldn't absorb and deliver anywhere. Well, guess who likes it? You couldn't break it down, but these guys are going to have a field day. Who? Yeah, the bacteria in your large intestine. Woo, party time! We don't typically get that stuff. She usually sucks it up before everything gets here. When bacteria grow at a rapid rate, you know what they also produce at a rapid rate? Gas. Yes. Gas, bloating, diarrhea. Pleasant, yes? So that's what sometimes when I can't break these down and they make it past where they should, bacteria have a field day. So they'll overproduce too much gas. Not so comfortable. Complex carbohydrates, big long chains of glucose molecules. We refer to them sometimes as polysaccharides. Starch, glycogen. Where's glycogen? Yeah, we store it. So when we bring in those glucose molecules, or however we bring them in and break them down and make them, we're going to take some of them and we're going to use them right away. What are we going to do with the extra? Store them up for a rainy day. Just like the plant did when it made it, you're going to store some. And you're going to store it in the form of glycogen. Fiber is a complex carbohydrate. The problem with it is, if I look at it molecularly, it's so tight in its carbon chains that I don't have the right enzymes to break it apart. Most of the carbohydrates that I break apart are kind of like bendy in their carbon chain. And I have the right enzymes, hopefully, to break them apart. But fiber, I don't have the right enzymes to break it down. So that is going to pass to the large intestine. And that's going to add bulk and allow things to move along. So starch, complex carbohydrate, polysaccharide. Glycogen, we find stored in the liver and in muscles, in animals like us. Fiber, where do I find fiber? In a plant? Where? No, actually, if I look at the cell of a plant, it's very similar to yours. It's got a plasma membrane all the way around it, but then it's got this extra layer around it. It's called a cell wall. And that's, correct. Why do they have cell walls? No, actually to give it what? Give it structure. It doesn't have a skeleton, does it? You don't pull out any bones when you eat your vegetables, do you? Seeds, yes. No bones, though, right? So it's going to give, it supports the plant. It allows the plant to raise up out of the ground and point towards the sun, and that's what we need if I'm a plant to make my carbohydrates. So it gives structure to the plant. Starch, complex carbohydrates, we find glucose in the form of a polysaccharide. So many, many, many of these guys stuck together form starches. If I take a piece of potato, a very small piece of potato, and I put it on my tongue, and I hold it in my mouth for a long time, guess what's going to happen? It's going to start breaking down because I have special enzymes in my mouth called amylase that are going to break apart those bonds and create this. If I hold it in there long enough, it's going to start to taste sweet because I'm going to fire off sweet receptors in my mouth because I will have broken down the complex carbohydrate into simple. It takes a long time, and we usually don't want to hold a piece of potato in our mouth for that long. Take my word for it. So we digest or break down that large molecule into glucose through the digestive process. Find it in grains. What's a legume?
Beans.
Yeah, beans. Again, some of us have problem with beans. They make us what? Gassy. Why? Yeah, a lot of fiber, a lot of complex carbohydrates. Now, what if my body, if I don't go through the digestive process well, if I combine it with other foods maybe that are being concentrated on a little bit more than my carbohydrates, I'm going to have larger carbohydrates make it to where? The large intestine. And party time, yes? So one of the tricks, you want to know a trick? When you eat beans, don't eat meat. Yeah, because you're chilly, right? Put meat and beans there. But try not to eat protein, meat, with beans. Make the beans your protein in that meal. It's a little bit easier for your body to digest. What's a tuber?
Like potatoes.
Yeah, potato, sweet potato, those things that grow under the ground. Glycogen stored in animals, so you store your glucose as glycogen. Liver, muscles. It breaks apart, so we don't typically find it in our food source. So it's not typically found as a source when I eat meat, which is kind of strange, isn't it? But remember, glucose is what? Carbon, hydrogen, oxygen. When it degrades, it's going to degrade into what? Carbon, hydrogen, and oxygen. So we're not going to find it as C6H12O6 a lot. Well, we will find some of them when we eat a piece of meat. But meat tends to be very low in what? Sometimes they don't even list them. Carbohydrates. Fiber, cellulose. Two kinds of fiber. We have soluble, insoluble. We talk about functional fiber. Extracted from plants, added to food, usually used as what? Anybody like ice cream? Do you ever see that ingredient on your ice cream package? Yeah, it's just a thickener. It's nothing that's bad. It comes from beans. We're good. Yep. That's what I say. You get your calcium. Both my children's bones were laid the foundation on some good, healthy ice cream eating during pregnancy. So we'll see this fiber material, cellulose comes from the plant. Again, guar gum comes from an extract of plants. Pectin, to make things thicker. Psyllium, actually kind of like, almost like glass, but different type of fiber. So when we look at total fiber in food, we see a combination of dietary fiber, which is non-digestible parts of plants, and then functional fiber, which is extracts of carbohydrate material. Soluble fiber is going to dissolve in water, easily digested by those bacteria in the colon. Remember, we have to feed those guys too. Citrus fruits, berries, oats, beans, reduces the risk of cardiovascular disease and type 2 diabetes by helping to lower cholesterol and glucose levels. And that's science. I'm not just throwing that out there because I like it. There have been studies to show that. Insoluble fiber generally doesn't dissolve in water. That makes sense. Whole grains, wheat, brown rice, husks of grains, and that's going to add your bulk. Your bulk is going to promote bowel movements. And again, bowel movements, not so bad. Pushing the trash along. Get rid of it. Helps reduce the risk of something called diverticulosis. Does anybody know what diverticulosis is? Yeah. When I look at the large intestine, it's not the greatest of designs. Is anybody sewing here? Do you ever want to make something with ruffles? What do? Do you know? You make this, I'll tell you. I won't put you on the spot. You make a big, large stitch across the material, and then you pull it a little tight. When you pull it tight, you ruffle the material. That's kind of what this little thing called the Taenia coli does to your intestines. It's kind of a tight little stitch that pulls the tube and puckers it a little bit and creates these little pouches called hostra. Well, if I pack them up with too much stuff that I'm sucking the water out of and leave it hanging there for a while, I'm going to cause those pouches to pucker a little bit more than they should. I might even cause them to pucker so much that they poke through the connective tissue that holds the tube all together. So did anybody try to get rid of their feces by straining to do so? That can cause these little pouches to pucker. So when you have too much constipation or you don't have regular bowel movements, you increase the chances of creating these little puckers through the connective tissue. They're called diverticula. And if something gets caught in the little pucker and starts to fester, it can cause them to inflame. And we go from diverticulosis to diverticulitis. Exactly. Itis is inflammation. Is that bad? Yes. Very painful. Can actually cause perforation. We don't want anything that's hanging out in the digestive system anywhere else but in the digestive system. Right?
That's why they sometimes do like various swab tests
to check. You can check the. Yep. And again, diverticula refers to that puckering of the tube. And typically when we talk about diverticulosis, we're talking large intestine, but it can happen higher up in the tube as well. So we don't want, that's why it's so important to have those regular bowel movements. Yes? If you don't go often, you have to reevaluate your diet. Yes? Energy. Carbohydrate, energy. So carbohydrates, C6H12O6, when we think of it, we should think of energy production. So it's our fuel for daily activity. It's our fuel for exercise. Not just exercise, but things like my heart beating and my brain having to do what it has to do on a daily basis, or me breathing in and out. So those are kind of important things. We don't think of, I go to the gym to breathe in and out, right? But those are very important things that I need energy for. Helps to preserve spare proteins for other uses. I can use proteins to make energy also. But do I want to do that? Chemically, it doesn't make sense for me to do that. What do I want to do with my protein?
Can I ask you a question?
Yes.
It's kind of maybe like diverting.
That's all right.
I think we'll focus. Do you watch The Biggest Loser?
I know of The Biggest Loser, yes.
It's like everywhere. She lost so much weight in such that short period of time. I mean, she looks, I think, really, really unhealthy. So my question
Because she is.
Oh, she looks really bad. She
Yeah.
lost like 165, 155 or 65 pounds. She went from like 300 to like 105.
Wow.
And I mean, she's like stick thin. So my question is, where's the line between like ketosis and things like that? Like, you know, we should exercise and things like that, burn the fats and get rid of it. But where is the line when you start taking all of
When your body breaks down fat at a rapid rate, one of the waste products, and I'm glad you brought that term into your description, is what we call ketone bodies. And they are very acidic. So when I break down fat at a very rapid rate, it's very difficult for my body's systems to deal with that influx of that acidic component at a very high rate. So it causes ketoacidosis when I burn fat at too high a rate. And I can guarantee anybody that lost that much weight in that time definitely was in what we call ketoacidosis.
which is bad?
Bad. It messes with your body's pH. Your body's pH is very important, and it needs to stay in a very tight range, 7.35 to 7.45. The reason for that is if I mess with too much acid or too much base, I'm going to start messing with the shapes of my proteins. When I start messing with the shapes of my proteins, they're not going to work the way they should. And that's going to screw up all kinds of chemistry, to put it bluntly. So your body's pH, in order to maintain it at a nice even level so that I can deal with the waste products of fat breakdown, they say, and it depends on your metabolism, between 1 and 2 pounds a week, max.
How fast is she
J-
Well, it was the show, so it's only like 12 weeks, 16 weeks.
No, it's probably, I'm guessing it's like 6 months. I can't believe she lost that kind of weight.
3 to 4 months.
Wow.
And then they go home for 4 weeks. So yeah, probably.
Like 6, yeah, 5, 6 months.
But I mean, you know, you watch the show and they lose 5 or 6 pounds and they're like, oh, you know, and when they hit 12 or 15, they're like, yay! And they, you know, it's like.
That's not good.
No. And
No.
so,
But the other thing we have to realize is the reason we gain that weight is because we have created habits which will cause us to take in excess calories. When you lose it that fast, do you change what made you there in the first place? Probably not. So I heard of the show. I'm not a fan of the show.
yeah.
I don't
This
think
is
it's
like,
smart.
It's everywhere. It's in the media. It's on Fox News. I mean, and it just goes. It's like questioning the show. But not only that, the trainers, because they're trying to push Subway and they're trying to push like healthy eating on the run and they're trying to push, you know, taking. You know, at the beginning of the show, they have full workups. They'll say, well, you have diabetes, and you have this, and you have that,
Yep.
and you have that. And so now they're questioning. Okay, well, let's look at what people have at the end of the show. How healthy are you? Really?
Yeah, really, exactly.
So it's like really a controversial thing right now about what really is healthy.
Right. And moderation. Just like we talked about taking foods in moderation, changing, you know, something like I need to lose extra weight. That should happen slowly.
Right.
If you want to change the habit that got you there, it has to happen
So
slowly.
even when you're that big, like some people on that show are like for 200 pounds. So
What's going to happen with somebody that heavy is they're going to lose weight fast in the beginning. Most of that weight is not fat. It's water. Okay? And then once that person is evened out with water distribution, then they'll fall into a slow range. But yes, and that's what's frustrating to us in the society, because what do we want? We want results today. We don't want to wait a year. Even though it took us 10 years to get there, we don't want to wait a year. I can't lose 1 pound a week. It's going to take me a year and a half. Well, yeah, it is. It's going to take you a year and a half. But if we do it that way, our body can handle the metabolism that's going on, the change in metabolism, and then we're going to tend to probably stay at that healthy weight once we reach it, because we've changed the habits that got us there in the first place. So, you know, no.
So in amongst losing, I guess my question was, in amongst losing the fat, the weight, you're also messing with your makeup of how your body is going to break down.
React to food, exactly. Exactly. And then when I starve myself, you know, the other extreme, your body's metabolism, those chemical reactions are going to go way, way down. That's why it's bad for you not to get your metabolism revved up by eating. If you want to lose weight, if you want to burn fat, what's the 2 best ways to burn fat? There's 2. Eat and exercise, exactly. Because when we look at fat metabolism, our muscles tend to like to use fat better. They'll use it to make energy. They don't care. They don't care if it's glucose or fat. We're good with the fat. So if I want to get rid of extra fat, if that's my goal, exercise and then eat, because you don't have enough energy if you don't get the carbohydrates and the nutrients into your body to do the exercise. So a lot of people will restrict calories way, way down. I'm on a 200-calorie diet. You need at least how many calories to get going? You know, on the average, that number 2,000 didn't come from space, you know. Yeah, it depends on your activity level, but you know, if you use that as your base, say 2,000 calories to maintain your weight. Now, if I want to lose weight, what am I going to do? I'm going to go down a little, but I'm not going to go down so much that I mess with my metabolism. Do you see what I mean? So, okay, if I want to lose weight, and it's depending on my size, say I take away 400 calories. I go on a 1,600 calorie diet. They're like, oh, I can't go on that. That's way too much. Well, no, it's not. What do you have to do with it? You got to exercise. And then you have to take your 1,600 calories and do what? Spread it out through the day. You can't starve yourself all day and then sit down and eat 1,600 calories for dinner, right? Because what are you going to do with the extra that you're not going to use that time? Whew, you're going to store it away.
My high school preseason, we used to have 3 practices instead of like double sessions in the morning. We didn't even do soccer. We ate breakfast in between, and then in the afternoon we had our workout and everything, and then we had dinner together.
Right.
For 3 straight weeks, and our soccer coach would just be like, eat. He's like,
Yeah.
it doesn't matter because you're using so much.
Exactly.
Soccer season.
You need that to do what you're going, to do the job that you were there to do. So that's the best way to lose weight. And again, it's going to take a long time. And what do we want to be gorgeous in a day. Slim fast. They call it slim fast for a reason, because it's going to make you beautiful in a day, right? So yeah, no, I don't agree with.
Right.
Huh? Yeah. There you go. I'll get a pizza and watch the Slim Fast commercial. We're good. So yeah, everything in moderation, and weight loss too. And weight gain. Some people, I'm always very jealous of them, have to gain weight. They don't have enough weight on them. That's my dream. I go to the doctors and he says to me, dear, too thin, you must gain weight. Yes. But no, the same thing with weight gain, because you want to do that at a nice even level. You want to put on muscle. You don't want to put on fat when you gain weight. So you want to bring in a few extra calories over. You don't want to do it big, just like you to lose weight. So if I say 2,000 calories, and again, that's different for all of us depending on our body size, then I take in an extra 300 calories that day. Exactly. It's our vision of what that perfect person should be. And the things that we do, it's like, don't bother. No, but they're like, they can't even breathe because they're sucked into those Spanx things, and they don't have to go to the ladies' room. They'll like starve themselves in no water for 3 days, so they don't have to go to the ladies' room and take off the Spanx, right? And then most of the people in magazines, are they real? No.
The girl from Hunger Games, she was quoted on the red carpet because somebody asked her, like, how she kept her food and she's like, what are you talking about? I eat all the time. And then she was like, French fries, burgers, and she was like going on. And they had a field day about it because she was so honest.
Yeah.
Some people can do that, though, for them to have it.
Right. And it all depends on our metabolism. Some people have a faster metabolic rate than others. Again, I'm very jealous of those people. But energy in, energy out. So that's the bottom line. Some of us burn energy at a faster rate, depending. And if, again, you want to burn energy at a faster rate, what are you going to do? Speed up your metabolism by doing those two things. Not just one, you got to do both. So for 1 gram of carbohydrates, 4 kilocalories. Couple of different players in the human body will only get their energy from C6H12O6. 1, red blood cells. I don't want any lipids. Don't even give them to me. I don't use them. I only use glucose. You know who else? Yeah, your nervous system. Anybody ever go on a very restricted carbohydrate diet? Yeah, the number that they quote is 20 grams of carbohydrates a day. What should you be eating? No, like 200. Yes? And that's kind of on the low side. So if I take 20 grams of carbohydrates a day, who's going to suck up whatever they possibly can? And this is why it works. This is why you get thinner faster. Because who's going to suck up those measly little 20 grams? Your red blood cells in your brain. Now when that starts to go down, you're going to break down glycogen. That's what you're going to do first. Then you can break down lipids, but who doesn't want that? Your brain. So what's going to happen to brain metabolism when I got nothing to eat? It's going to go way down, right? I'm going to conserve what little I have. If you're stuck in the wilderness and you have a Snickers bar, you're not going to eat the whole Snickers bar because you know you're stuck in the wilderness. So what are you going to do? Ration it. I wouldn't be very good in the wilderness because I'd probably... Damn. So that's what your brain's going to do. And what happens to people? Sometimes one of the big complaints on people on these diets is what? Oh my gosh, I'm tired of this. Oh my God, I can't even finish a thought. Why? Because they don't get enough carbohydrates to drive metabolism in their brain. Yes, it breaks down fat faster. But it also, what did we talk about when I break down fat too fast? Ketosis, exactly. So, carbohydrates and fats supply daily energy for things that cause my muscles to move. Glucose is especially important during exercise. I'm going to talk about that in this class too. But it's quick energy versus sustained energy. So if and I always tend to talk about wanting to lose weight, but apply the opposite to wanting to gain weight. If I want to lose weight, I want to use more fats. Yes? What kind of exercise should I do? Speed up the heart rate. Not just that. Yeah. So we always think, I have to go on the treadmill and I have to sweat until I die and run way too fast, right? Because that's going to do it for me. Is that doing it for you? No. Because you know what you're going to use to do that? Glucose. Wait a minute, I want to use fat. What's going to allow me to use the fat? Get on the same treadmill, but don't run. What are you going to do? Walk. Moderate exercise. So what we define as moderate exercise will burn much more fat than killing myself. Huh?
I feel like it makes no sense though.
But think about it. If I can use that source at a slower rate, moderate exercise, I can break those lipids down and use them. If I need it immediately because you are pushing your muscles way too hard, I need to get something quick. And what's quick? Glucose.
I know a person who did a mile loop trail by her house 3 times a day, like after every meal, and she lost so much weight.
Yeah.
Compared to like one of her friends who went running every morning.
It doesn't matter. Distance matters. Doesn't matter. Time doesn't matter. Do you see what I'm saying? So if I walk a mile, I use X amount of energy. If I run the mile, I'm still going to use X amount of energy. A mile's a mile. Pushing my muscles to move that mile. Right? It just takes me longer to do the other one. And again, we're very impatient in our society. So if I'm going to do a mile, I'm going to run it. Yes? But if you walk it, and not, not like walk, above 3 miles per hour pace, a good pace, you're going to burn more fat. So we'll see it. It's in the book. It's science. I'm not just saying it. So during intense exercise, carbohydrates going to be 2/3 of our total energy needed. So don't go on the intense end. And remember, muscles like fat, right? So don't just do the walking. What else should you do? Lifting weights. So Tuesdays and Thursdays is weight day at the gym. Monday, Wednesday, Friday is cardio days at the gym. 5 days. That's what I do every day, every week. 5:15 in the morning, I get up and I go to the gym. Yep, crazy. But I've realized I've been struggling with weight for years and years, and realized, okay, even though I don't like this, even if I don't lose weight doing this, what's this going to help me do? Yeah, my joints will feel better. Maybe I'll kick my metabolism in eventually. My metabolism's kind of on vacation. But it's just going to make you feel better all around. And that's a habit, the one little habit that you can change to get you towards, a healthier lifestyle. So energy, very important. Sufficient energy intake from carbohydrates prevents production of those ketone bodies. Ketone bodies are going to be used as an alternate energy source from the breakdown of fat. Too much ketone bodies is going to result in ketoacidosis. So we're going to take that pH, 7.35 to 7.45, and do what to it? Make it lower. High blood acidity is going to mess with the shape of my proteins, basically. And when I unfold the proteins, does anybody know what that's called? When I mess with the shape of proteins? Denature. And when I don't have them folded just right, they can't do their job the way they should. Remember those enzymes we talked about for the digestive process? Guess what they are? They're proteins. So if I mess up with my proteins, I'm going to mess with that function. So we'll pick up with fiber on Wednesday. I'm going to open up the quiz for you Oh, I didn't take attendance. Wait a minute. Let me take attendance really quick. It's going to be due, yeah.